Physics. So we'll be dealing with position, distance and displacement today. Position, distance and displacement. Position is the direction of an object from a particular reference point, or you can say from a reference point. Let me give you an example now. Look at this box here. How do I estimate the position of this box? I don't know. So it depends on where I'm looking at this box from. I could be looking at this box from this direction. I could be looking at this box from this direction. I could also be looking at this box from a direction like this. So these ones, we call them coordinates. We call them coordinates. So it could be like this. So sometimes you can call this one X coordinate. This one that looks horizontal, you can call this one Y coordinate. You can call this one Z coordinate. So that is why you always see position in the form of a bracket. So this is X position, this is Y coordinate, this is Z coordinate. Sometimes it could be only X and Y. If it is a 2D object, like a box, like a flat paper, it is only X and Y. But if it is an object that is robust, a body that has 3 positions, like a book that has length, breadth and height, then you say X, Y and Z. So this one is 3D. X and Y is 2D. What about distance? So distance is a measure of how far an object has traveled from its starting point. Or you can say it is a measure of how far an object is from its starting point. Look at this box here. How far is it from this place? From here. So that distance, that gap is the distance. So it's the gap there. So distance can be measured anyhow. It could be a snake moving this way, moving this way, moving this way. You could just measure the whole thing. Just measure the entire distance from this point A to this point B. So it doesn't have to be a straight line. It could be a bent line. So this place here, we call it reference point. So I can say this is a reference point. Reference point is that point where you are measuring from. So the reference point is a coordinate system. It is a coordinate system. Just like this one here. This place is a reference point. This particular position is reference point. It is from here that you are measuring every other thing. It is from here that you are measuring every other thing. So if there is no position, you cannot talk about distance. If there is no position, you cannot talk about displacement. So we'll be moving next to displacement now. Displacement. So you can say it is the change in an object's position. It is the change in an object position. Look at this box here. The object has moved to this new position. This was the object's former position. It has now moved to this new position B. So that change there, that's displacement. Displacement is usually a straight line. In fact, sometimes you can say it is the shortest distance between 2 points. If you were supposed to move from this point A to this point B in a zigzag manner or in a curved manner like this, this point A here to this point B can also be in a straight line like this. This straight line here is the displacement. So displacement is usually like the shortest distance between 2 points. So this straight line here is the displacement. So it usually has a particular direction. But you see, if you move this zigzag manner, this curved manner, that is distance. Distance does not care whether the line is straight or not. It's just anyhow. The most important thing is get to the destination. So distance does not have direction. It is just anyhow. But displacement has direction. So if you want to define displacement, you can say displacement is the shortest distance between two. So you can see it here now that it is the shortest distance. I said you can see it is the shortest distance between any 2 points. Between any 2 points. Take note, shortest distance between any 2 points. Now, this distance here, we call it vector quantity. This is a vector quantity. It's a scalar quantity rather. It's a scalar. It's a scalar quantity. Scalar quantities are quantities that have only magnitude but no direction. Take note, scalar quantities are quantities that have only magnitude but no direction. But displacement is a vector quantity. Displacement is a vector quantity. Distance is a scalar quantity. Don't forget, scalar quantities are quantities that have magnitude but no direction. Vector quantities are quantities that have both magnitude and direction. Magnitude means size. Magnitude means size. That is number. So they have both number and they have direction. For this one, this distance, they just have only number, but they don't have direction. Position. This position is a vector quantity because it has direction. It can be X, it can be Y, it can be Z. So position is a vector. Distance is a scalar. Displacement is a vector.